Section 3.3, Building a RESTful Application with Spring MVC. If you're building cloud-native applications, chances are that you are working on a distributed system composed of several services, such as microservices, interacting with each other to accomplish the overall functionality of the product. Your application might be consumed by a service developed by another team in your organization, or you might be exposing its functionality to third parties. Either way, there's an essential element in any inter-service communication, the API. The 15-factor methodology promotes the API-first pattern. It encourages you to establish the service interface first and work on the implementation later. The API represents a public contract between your application and its consumers, and it's in your best interest to define it first thing. Suppose you agree on a contract and define the API first. In that case, other teams can start working on their solutions and develop against your API to implement their integration with your application. If you don't develop the API first, there will be a bottleneck, and other teams will have to wait until you're done with your application. Discussing the API up front also enables productive discussions with stakeholders, which can lead to you clarifying the scope of the application and even defining user stories to implement. In the cloud, any application can be a backing service for another one. Adopting an API-first mentality will help you evolve your applications and adapt them to future requirements. This section will guide you by defining a contract for catalog service as a REST API, the most used service interface model for cloud-native applications. You'll use Spring MVC to implement the REST API, validate it, and test it. I'll also outline some considerations for evolving an API for future requirements, a common issue in highly distributed systems like cloud-native applications. Section 3.3.1, REST API first, business logic later. Designing the API first assumes you have already defined the requirements, so let's start with those. Catalog service will be responsible for supporting the following use cases. View the list of books in the catalog. Search books by their International Standard Book Number, ISBN. Add a new book to the catalog. Edit information for an existing book. Remove a book from the catalog. In other words, we can say the application should provide an API to perform CRUD operations on books. The format will follow the REST style applied to HTTP. There are several ways to design an API to fulfill those use cases. In this chapter, we'll use the approach described in Table 3.1.
Table 3.1. Specifications for the REST API that will be exposed by catalog service. View table figure.
Documenting APIs. Documenting APIs is an essential task when you're following the API-first approach. In the Spring ecosystem, there are two main options. Spring provides a Spring REST Docs project, see this link, that helps you document REST APIs via test-driven development, TDD, resulting in high-quality and maintainable documentation. The resulting documentation is aimed at people, relying on formats like ASCII-Doc or Markdown. If you'd like to obtain an Open API representation as well, you can check the REST Docs API Spec community-driven project to add Open API support to Spring REST Docs, see this link. The SpringDoc Open API community-driven project helps automate the generation of API documentation according to the Open API 3 format, springdoc.org. The contract is established through the REST API, so let's move on and look at the business logic. The solution is centered around three concepts. Entity. An entity represents the noun in a domain such as book. Service. A service defines the use cases for the domain. For example, adding a book to the catalog. Repository. A repository is an abstraction to let the domain layer access data independently from its source. Let's start with the domain entity. Defining the domain entity. The REST API defined in Table 3.1 should make it possible to operate on books. That's the domain entity. In the Catalog Service project, create a new com.polarbookshop.catalogservice.domain package for the business logic and create a book Java record to represent the domain entity.
Listing 3.4. Using the book record to define a domain entity for the application.
Implementing the use cases. The use cases enumerated by the application requirements can be implemented in a service class. In the com.polarbookshop.catalogservice.domain package, create a book service class, as shown in the following listing. The service relies on some classes that you'll create in a minute.
Listing 3.5. Implementing the use cases for the application.
Note: the Spring framework provides two flavors of dependency injection, constructor-based and setter-based. We'll use constructor-based dependency injection in any production code, as advocated by the Spring team, because it ensures that the required dependencies are always returned fully initialized and never null. Furthermore, it encourages building immutable objects and improves their testability. For more information, refer to the Spring framework documentation. See this link. Using the repository abstraction for data access. The book service class relies on a book repository object to retrieve and save books. The domain layer should be unaware of how data is persisted, so book repository should be an interface to decouple the abstraction from the actual implementation. Create a book repository interface in the com.polarbookshop.catalogservice.domain package to define the abstraction for accessing book data.
Listing 3.6. The abstraction used by the domain layer to access data.
While the repository interface belongs to the domain, its implementation is part of the persistence layer. We'll add a data persistence layer using a relational database in Chapter 5. For now, it's enough to add a simple in-memory map to retrieve and save books. You can define the implementation in an in-memory book repository class located in a new com.polarbookshop.catalogservice.persistence package.
Listing 3.7. In-memory implementation of the book repository interface.
Using exceptions to signal errors in the domain. Let's complete the business logic for catalog service by implementing the two exceptions we used in listing 3.5. Book already exists exception is a runtime exception thrown when we try to add a book to the catalog that is already there. It prevents duplicate entries in the catalog.
Listing 3.8. Exception thrown when adding a book that already exists.
Book not found exception is a runtime exception thrown when we try to fetch a book that is not in the catalog.
Listing 3.9. Exception thrown when a book cannot be found.
That completes the business logic for the catalog service. It's relatively simple, but it's recommended not to be influenced by how data is persisted or exchanged with clients. The business logic should be independent of anything else, including the API. If you're interested in this topic, I suggest exploring the concepts of domain-driven design and hexagonal architecture. Section 3.3.2. Implementing a REST API with Spring MVC. After implementing the business logic, we can expose the use cases through a REST API. Spring MVC provides REST controller classes to define methods that handle incoming HTTP requests for specific HTTP methods and resource endpoints. As you saw in the previous section, the dispatcher servlet component will invoke the right controller for each request. Figure 3.6 shows the scenario where a client sends an HTTP GET request to view the details of a specific book.
Figure 3.6. The processing flow for an HTTP GET request arriving at the /books/ISBN endpoint.
We want to implement a method handler for each use case defined in the application requirements, since we want to make all of them available to clients. Create a package for the web layer, com.polarbookshop.catalogservice.web, and add a book controller class responsible for handling HTTP requests sent to the /bookspace endpoint.
Listing 3.10. Defining handlers for REST endpoints.
Go ahead and run the application, /gradle boot run. When verifying HTTP interactions with an application, you can either use a command line tool like curl or software with a graphical user interface like Insomnia. I'm going to use a convenient command line tool called httpy, httpy.org. You can find information about how to install it in section A.4 of Appendix A. Open a terminal window and perform an HTTP POST request to add a book to the catalog.
See this code?
The result should be an HTTP response with the 201 code, meaning that the book has been created successfully. Let's double-check by submitting an HTTP GET request to fetch the book with the ISBN code we used on creation.
See this code?
When you're done trying the application, stop its execution with Control-C. About content negotiation. All handler methods in Book Controller work on Book Java objects. And yet, when you perform a request, you get back a JSON object. How is that possible? Spring MVC relies on an HTTP message converter bean to convert the returned object into a specific representation the client supports. The decision about the content type is driven by a process called content negotiation, during which the client and the server agree on a representation that both can understand. The client can inform the server about which content types it supports through the accept header in the HTTP request. By default, Spring Boot configures a set of HTTP message converter beans to return objects represented as JSON, and the HTTP tool is configured to accept any content type by default. The result is that both client and server support the JSON content type, so they agree on using that to communicate. The application we have implemented so far is still not complete. For example, nothing prevents you from posting a new book with an ISBN in the wrong format or without specifying a title. We need to validate the input. Section 3.3.3 Data Validation and Error Handling. As a general rule, before saving any data, you should always validate the content, both for data consistency and security reasons. A book with no title will be of no use in our application, and it would probably make it fail. For the book class, we might think of using these validation constraints. The ISBN must be defined and in the correct format, ISBN 10 or ISBN 13. The title must be defined. The author must be defined. The price must be defined and be greater than 0. Java Bean validation is a popular specification for expressing constraints and validation rules on Java objects via annotations. Spring Boot provides a convenient starter dependency containing the Java Bean validation API and its implementation. Add the new dependency in the build.gradle file for your catalog service project. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 3.11. Adding dependency for Spring Boot validation.
You can now use the Java Bean Validation API to define validation constraints as annotations directly on the book record fields.
Listing 3.12. Validation constraints defined for each field.
Note: books are uniquely identified by their ISBN, International Standard Book Number. ISBNs used to be composed of 10 digits, but they now consist of 13. For simplicity, we'll limit ourselves to checking for their length and whether all the elements are digits by using a regular expression. The annotations from the Java Bean Validation API define the constraints, but they are not enforced yet. We can instruct Spring to validate the book object in the Book Controller class by using the valid annotation whenever a request body is specified as a method argument. In this way, whenever we create or update a book, Spring will run the validation and throw an error if any constraint is violated. We can update the post and put methods in the Book Controller class as follows.
Listing 3.13. Validating books passed in a request body.
Spring lets you handle error messages in different ways. When building an API, it's good to consider which types of errors it can throw, since they are just as important as the domain data. When it's a REST API, you want to ensure that the HTTP response uses a status code that best fits the purpose and includes a meaningful message to help the client identify the problem. When the validation constraints we have just defined are not met, a method argument not valid exception is thrown. What if we try to fetch a book that doesn't exist? The business logic we previously implemented throws dedicated exceptions: book already exists exception and book not found exception. All those exceptions should be handled in the REST API context to return the error codes defined in the original specification. To handle errors for a REST API, we can use the standard Java exceptions and rely on a REST controller advice class to define what to do when a given exception is thrown. It's a centralized approach that allows us to decouple the exception handling from the code throwing the exception. In the com.polarbookshop.catalogservice.web package, create a book controller advice class as follows.
Listing 3.14. The advice class defining how to handle exceptions.
The mapping provided in the REST Controller Advice class makes it possible to obtain an HTTP response with status 422, unprocessable entity. When we try to create a book that already exists in the catalog, a response with status 404, not found. When we try to read a book that doesn't exist, and a response with status 400, bad request, when one or more fields in a book object are invalid. Each response will contain a meaningful message that we defined as part of the validation constraint or custom exception. Build and rerun the application, /gradle w boot run. If you now try to create a book without a title and with a wrongly formatted ISBN, the request will fail.
See this code.
The result will be an error message with a 400 bad request status, meaning that the server couldn't process the HTTP request because it was incorrect. The response body contains a detailed message about which part of the request was incorrect and how to fix it, just as we defined in Listing 3.12.
See this code?
When you're done trying the application, stop its execution with Control-C. That concludes our implementation of the REST API that exposes the catalog service's book management functionality. Next, I'll discuss a few aspects of how we can evolve APIs to adapt to new requirements. Section 3.3.4, Evolving APIs for Future Requirements. In a distributed system, we need a plan to evolve APIs so we don't break the functionality of other applications. This is a challenging task because we want independent applications, but they probably exist to provide services to other applications, so we are somewhat limited in the number of changes we can make independently of the clients. The best approach is to make backward-compatible changes to the API. For example, we can add an optional field to the book object without affecting the clients of the catalog service application. Sometimes breaking changes are necessary. In this situation, you can use API versioning. For example, should you decide to make a breaking change to the REST API for the catalog service application, you might introduce a versioning system for the endpoints. The version might be part of the endpoint itself, like /v2/books. Or it might be specified as an HTTP header. This system helps prevent existing clients from breaking, but they will have to update their interface to match the new API version sooner or later, meaning that coordination is needed. A different approach focuses on making the REST API client as resilient to API changes as possible. The solution is to use the hypermedia aspect of the REST architecture as described by Dr. Roy Fielding in his doctorate dissertation, Architectural Styles and the Design of Network-Based Software Architectures. See this link. REST APIs can return the object requested along with information about where to go next and links to perform related operations. The beauty of this feature is that the links are only shown when it makes sense to follow them, providing information about when to go. This hypermedia aspect is also called HATUS, hypermedia as the engine of application state, and it represents the highest level of API maturity according to Richardson's maturity model. Spring provides the Spring HATUS project to add hypermedia support to a REST API. I will not use it in this book, but I encourage you to check the project's online documentation at this link. These considerations conclude our discussion of building a RESTful application with Spring. In the next section, you'll see how to write automated tests to verify the behavior of your application.